Okay, salam semua.
Salam, madam.
Alright, so today we continue with our topic. Okay, this is the next chapter, which is the magnetostatic. Okay, so in magnetostatic, it comprises of Biot-Savart law, we have Ampere's law, and then the last one is inductance. Okay, so it's a bit similar with this electrostatic. Okay, so because electrostatic we deal with charge distributions, while for the magnetostatic will we are using these current distributions. Okay. Right. So before this electrostatic, okay, so static charge produce electrostatic field ataupun electric field intensity E, and then from there you can find the electric flux density D, okay, where you know that D is epsilon E. But for this magnetostatic, it is we consider a moving charge, okay, instead of a static charge for electrostatic. For here, it is a moving charge, but the charge is moving in a constant velocity. Okay, so when it moves with constant velocity, it will produce what we call as a magnetostatic field. Okay, and this is we normally use H for this magnetostatic field intensity, and then B for magnetic flux density. Okay, and then you can see here for electrostatic, we know that if we have a 1-point charge, and this charge will produce this electric field all around the charge itself, okay, in that directions. Okay, so this point charge will produce the electric field in all directions from the point charge. But when we look about this magnetostatic, if we have a single line like this, and this line, the charge will move from one point to another point, okay, because we are considering the moving charge, right? And this charge is moving from one point to another point with constant velocity, and in the same time it will produce what we call as this magnetic field intensity. And this magnetic field intensity, it will produce some sort like this one, dia macam curl, okay, surrounding this line current. Okay, you can see in the figure here. So this is the magnetic field intensity. Okay, so it's moving like a curl surrounding the line current. All right. Okay, so in the same time, it will produce this what we call as a constant current flow ataupun direct current. Okay, right. So again, this electric field, it characterizes E and D, which is field intensity, and also D for flux density. But for magnetic field, we characterize it by H for the intensity and B for the flux density. And the equations for flux density is B equals to mu H, where mu is the permeability of a material. All right. So here you can see the analogy between electric and magnetic field. So you can see here for electrostatic, we have this Coulomb's law where F equals to Q1, Q2, the charge. Okay, because this Coulomb's law is a law that produced between two charge or more than one charge. Okay, so that's why we have Q1 and Q2 times the directions and divide by 4 pi epsilon r cube. Okay, and then we have this for the magnetic field ataupun magnetostatic, we have this what we call as a Biot-Savart law. So Biot-Savart law is a bit similar with this Coulomb's law. So before this, we have Coulomb's law. We need to find E equals to integrations of Q okay, ataupun integrations of rho LDL or rho SDS or rho VDV divided by 4 pi epsilon R cube. Okay, but for here it's similar to this apa charge distributions for the electric ataupun electrostatic. So in magnetic field intensity we have this B is equals to integrations of I dl cross. This is cross ya, nanti kamu akan nampak from the next slide. So I dl cross UR is this the directions. Okay, selalu kita gunakan AR kan. So this is the directions divided by 4 pi r cube. Okay, and then for the next one, for the electrostatic, we have a Gauss law. Okay, and you know that Gauss law state that flux equals to Q and close. Okay, and then flux is equal to dl, and then this Q and close is depending on the how many transition surface are there inside the systems. Okay, that we have this Gauss law. But for the magnetostatic, we have this what we call as Ampere's law. Okay, and then you can see here Ampere's law is that flux equals to I and close. Okay, so it's similar with this Gauss law. If you look here, D.ds and this is H.dl. Okay, because this for the magnetic ataupun magnetostatic wing with this current distributions. Okay, so we have this flux is equals to H.dl, and this H.dl is equals to current enclosed by that uh, yeah. Okay, so we have this Ampere's law, and then other than that, we have Force law, field intensity, flux density, and the relationship between the field. Okay, we have D and also we have B, right? Okay, so there are two major laws governing in a magnetostatic field. So, like I said, we have Biot-Savart law. Okay, like Coulomb's law, it is the general law for magnetostatics. And then we have this Ampere circuit law. Okay, so this is like Gauss law, a special case of Coulomb's law, and this ACL ataupun Ampere's law is a special case of Biot-Savart law. Okay, and then again, can easily apply problems involving symmetrical current distributions. Right, so before this, we are dealing with symmetrical charge distributions, but now in magnetostatic, we are dealing with symmetrical current distributions. Okay, so this one, electrostatic different charge distributions. But in magnetostatic is different current distribution, which are line current, surface current, and volume current. So whatever the distribution now we are considering, related to current. So we have line, surface, and volume current. Okay, so we go to Biot-Savart law. All right, so this is definitions for Biot-Savart law, where we have this, the magnetic field intensity H. Okay, so the magnetic field intensity H at this observation point is proportional to the product of current and its element, or we can call it as IDL. Okay, and then inversely proportional to the distance squared along the direction joining them. Okay, so you can see here, so H is equals to integrations of I dot dl cross AR divided by 4 pi R squared. Okay, so before this we just IDL AR divided by 4 pi R cube, R squared. But now for this Biot-Savart law, we are using this cross product instead of dot product. Okay, so this is cross product. So I hope you still remember how to calculate using cross product. Yeah. Okay, so again, if we change AR to this R, so it will be IDL cross R divided by 4 pi R cube. Okay, and then the unit is amperes per meter. All right, so that is for H. But for B is the flux density. So B is equals to mu H. So it's equals to mu times the integrations of IDL cross AR divided by 4 pi R squared. equals to mu times I GL cross R divided by 4 pi R cube. Okay, and then this is the unit for H ataupun the magnetic field intensity is amperes per meter, and the unit for the flux density is Weber per meter squared ataupun Tesla. Alright, okay, so this is we need to know what is the directions of this magnetic field intensity, and also what is the directions of the currents. Okay, so if we want to determine these two directions, we can use this what we call as the right hand thumb rule ataupun right hand rule. Okay, the right hand thumb pointing the directions of the current, and the finger is encircling the wire in the directions of DH. So if you take your hand, okay, and then you do it something like this, you can see that if the current is going upwards like that, okay, so your thumb will showing the directions of the current, and your finger, your four other fingers, will show the the directions of the magnetic field intensity. Okay, so it will look something like this. So the current will showing, the thumb will show the directions of the current, and the other four finger will show the directions of the magnetic field intensity. Okay, DH. All right. So here also showing the right hand rule. So again, this is showing the directions of the current, and this is showing the directions of the magnetic field intensity. Ataupun we can use this what we call as right-handed screw. So kamu boleh nampak, so if the current is going downward like that, your magnetic field direction will go clockwise, something like that. Okay, so kamu boleh try guna your own hands, and kamu boleh tengoklah which one is the current and which direction is the magnetic field. Okay, so here is showing, let's say this rod over here, let's say it is a current. Okay, and you can see this blue and red arrow showing the encircling the magnetic field intensity, encircling the rod itself to show the directions of the magnetic field intensity. Okay, all right. So another symbol that represent the directions of magnetic field is this one. Okay, so magnetic field intensity H or current I by a small direction in a dot or a cross sign. So it can show that either magnetic field intensity ataupun current, okay, dalam bentuk simbol something like this. So this is also showing the directions of the current ataupun the magnetic field going out ataupun going upwards. Okay, and this is showing the current ataupun the magnetic field is going inside ataupun going down. Okay, so you can see that. So let's say we have this one. Okay, take your right hand rule. Okay, you can try using your hand. Let's say this is your current. So current is pointing upwards. Okay, so your magnetic field intensity direction will be counterclockwise. Okay, for this one. Okay, so your thumb is showing upwards. Okay, because this is going up, right? This symbol is showing going up. Okay, so your thumb is going up, and then the directions of your magnetic field intensity will be counterclockwise. Okay, and please try this one. This is, let's say this is I, showing the I, okay, for current. So this is a symbol showing that the current is going down. Okay, the current is going down. So you can try using your right hand. Okay, so when the current is going down, so the directions of the magnetic field intensity will be clockwise. Okay, boleh ya? Boleh try semua? Dapat?
Boleh. Dapat.
Boleh.
Right. Okay, so this is the distributions of a current. So again, kalau kamu nampak before this in electrostatic, we have this line charge, surface charge, and volume charge. So now we are having this line current. So you can see here, H is integrations of IDL cross AR. Okay, if surface, we have these integrations of KDS cross AR. And then for volume, we have integrations of JDV cross AR. Okay, but in this course, we only cover only one, which is only line current sahaja. Okay, so remember kita just cover line current sahaja. The surface current and volume current kita tak cover untuk Biot-Savart law. Okay, this one kita akan cover dalam Ampere's law sahaja. Alright, so you can see here, cara dia semua nanti sama juga macam this charge distribution using Coulomb's law yang kita belajar dekat electrostatic. Alright, so this one, identify the configuration that is not a correct representing I and H. Okay, for A, is it betul ataupun salah?
Betul.
Is it betul ataupun salah? When your I is pointing upwards, your directions of H will be counterclockwise. So betul, right? Okay, B, is it betul atau salah?
Salah.
Ha.
Betul.
Betul.
Ha. Okay, so this is symbol representing that the current is going upwards, and this is your magnetic field intensity. So is it betul atau salah?
Betul.
Betul. Okay, good. So this one, is it betul ataupun salah?
Salah.
Salah.
So dia sepatutnya going upwards, right? Okay. So this one, is it betul ke atau salah?
Betul.
Salah.
Syami?
Juga salah. Betul.
Betul, Syami. So
Sebab
again,
current
using
kat
your
sini.
right hand rule, kamu tengok your current is going that way. So your magnetic field is going upwards. Betul tak? Kan?
Betul.
Your
Saya cakap
magnetic
tengok
field.
simbol.
Tengok symbol. So your magnetic field is going upwards. Okay, so this is symbol for upwards. Alright, so yang the last one, is it betul atau salah?
Betul juga.
Ha?
Betul. Betul lah ni. Betul.
Okay,
Yakin.
so this is betul. So let's say the current is going towards you. So your magnetic field directions will be going down this way and going up on the right side. Okay. Alright, so this is kita sampai dia punya part of calculations. So let's say example 1, we have this infinite long straight filamentary current I is along z-axis, this orange color. So a point P in the Z equals to 0, plane is selected. Determine the magnetic field intensity at point P. So you need to find the magnetic field intensity at point P. All right, so what is the first thing that you need to do? Cara dia sama je macam electrostatic. Okay, before this. Cuma dia hanya gunakan current. So what is the first thing that you need to do? Anyone can answer?
Choose right formula.
Okay, choose the right formula. Okay, so what is the right formula for this? What is the right formula?
Integration IDL plus R over 4 pi r square a cube.
Okay, betul. Okay, so because of this is line current, so we need to use that H equals to integrations of IDL cross AR divided by 4 pi R cube, R squared. Okay, right. Then what we need to do after that? Kita dah ada the equation, so what we need to do next?
Find the parameter.
Okay, find the parameter. So what parameters that we need to find?
R,
Okay, R,
DL.
DL, lagi?
Vector
Another
R.
one,
I.
magnitude. I dia akan bagi. Okay, the magnitude. Alright, so, okay, so here, you can see that this is the step. So step dia sama juga like before. So choose and write the right formula. Okay, so then we need to identify the parameters. We substitute the parameters. And sometimes we need to use this identity test. And then the last one, we need to solve the problems. Okay, so first one, we know that because kita just cover line current sahaja. So again, the equation is H equals to integrations of I dl cross R divided by 4 pi R cube. Alright. Kita dah tak ada epsilon kat sini ya. So 4 pi R cube. Okay, so the next one is we need to determine what is R, magnitude R, and also what is DL. So if we look back into this, so what is R? So again, how to draw R is we look again with the distribution. So for this is the current. So current start from negative infinity to infinity. So what we can do is that we draw the line from the starting point of the current here. Okay, this is the starting point, let's say. So we draw the line from the starting point of the current here towards the point of observation P. Okay, daripada starting point towards the point of observation P. So that will be your R. Okay, that will be your directions. Okay, and then how to find your R? Okay, how to determine what is R? So R will be the other directions to the observation point. So kalau tadi kita punya direction is from here to here, so the other direction to observation point is from here to the origin and towards the point of observations. Okay, so again saya ulang. So we know that the directions of R ni starting from the start point of the current towards the observation point, and then another way to observation point is starting from here towards the origin and towards the observation point ataupun jalan lain untuk ke observation point. Okay, so R is equal to what? What is R?
Negative Z.
What is R? R equals to what?
Negative Z tambah Y. Negative Z A Z tambah Y A Y.
Negative Z A Z tambah
Y A Y.
Betul.
Okay, so betul?
Betul.
Betul.
Yang lain?
Rasanya ZAZ tambah Y.
Z A Z tambah Y.
ZAZ tambah YAY. Sebab direction Z tu ke atas.
Okay, so direction Z is ke atas. So meaning that ia adalah positive, right?
Ya, betul.
Okay, and then next one will be A.
Yeah.
Y-A-Y.
Row.
Ha. Is it row ataupun Y? Tadi dia kata negative. So someone dah confirmkan dia adalah positive because it's going upwards. So Z adalah positive. So now to this side. So is it Y ataupun is it row?
So,
Row.
Okay, so dia adalah row. So if you look here, when the current is going upwards like that, so what is the directions of your magnetic field?
anti-clockwise.
Huh?
Anti-clockwise.
Anti-clockwise.
Yes, anti-clockwise. So it will produce some sort like cylinder kan? Betul tak?
Betul.
Ha, okay. So bila the current going upwards, dia akan bentuk some sort like a cylinder surrounding the current. So bila dia bentuk dalam dalam bentuk cylinder something like this, so kita kena gunakan rho as your parameters. Okay, so now R is equal to positive Z because it's going upwards. Bukan negatif ya, Nabila ya tadi. Bukan negatif ya, naik atas. So look at the directions of the current, it's going upwards. So it is positive Z AZ. And then it goes to direction ataupun towards the right side macam ni, towards P. So that will be rho A rho, positive rho A rho because it's going outwards. Okay, selalu kita guna ke dalam macam tu kan. So kalau dia go inside, that will be negative rho A rho. Tapi now dia go that way. Okay, lukis dia punya arrow. So the arrow will be here going upwards and here is going outwards. Okay, so it will be Z A Z plus rho A rho. So siapa yang tak faham lagi? Anyone yang tak faham, please.
Madam.
Okay, yes,
So,
Syam.
okay. So dia yang ni, yang current ni kan. Memang pakai row je lah kan. Dia tak pakai R langsung kan.
R?
Memang dia tak.
R memang tak lah. R
Tak,
is sphere.
Okay.
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 Dia hanya gunakan cylinder coordinates. Alright.
Okay. Thank you.
Okay. So that is your R. So your magnitude R will be rho squared plus Z squared and then square root the whole thing. Okay. So next, bila kamu dah dapat all the parameters, okay, this is all the parameters. So what you need to do now is to substitute all these parameters into the equation. So we have I dl just now. So your dl is dz az. Okay. So dl dia adalah dz az. Kalau kita tengok the direction is on z axis kan? Okay. So that's why dl dia adalah dz az. Alright. So masukkan dalam these equations and you will get something like this. So before you continue, what you need to do is that you need to deal with this cross product dulu. Okay, kalau dulu dekat electrostatic, we just bila kita dah substitute, so now we need to consider which one is symmetry kan. So which one is symmetry, then it will equal to 0. Tapi for here, we need to deal with this cross product ni dulu. Okay, so what you need to do is take out this dulu, dl cross r. So cari dulu what is dl cross r. So for this one, dl dia adalah dz az. Dia cross dengan z az plus rho a rho. Okay. So how to do this cross product? So still remember lagi macam mana nak buat cross product ni? Do you still remember? Macam mana nak buat cross product? So dz az cross z az plus rho a rho. So what will be the answer? Apa jawapan dia? What's the answer for this? Anyone? Kamu dah belajar kan?
Di Z darab dengan Z kosong.
Di ZAZ darab cross product dengan ZAZ will be?
Kosong.
Why is it kosong? Kenapa kosong, Syami? Kenapa kosong tak tahu?
Tak tahu.
Tapi macam mana kamu tahu dia kosong?
Kalau di Z darab dengan Z kosong lah. Bukan macam tu.
Kalau this one di ZAZ darab dengan row A row?
Bukan kosong.
Bukan kosong. Okay, so macam tak ingat je semua ni. Okay, so go back to your cross product balik. If you look here, okay, look at this diagram. Alright, so you need to draw something like this, which is kita ada arrow, AV and AZ. Okay, so arrow, AV and AZ. So arrow cross dengan AV, you will get AZ. Okay, arrow cross dengan AV, so what is opposite it? Apa opposite dia? Adalah AZ. So arrow cross dengan AV akan dapat AZ. AV cross dengan AZ akan dapat arrow. AZ cross dengan arrow akan dapat AV. Dapat semua?
Tidak.
Tidak. Okay, now we're dealing with this what we call as cross product. Okay, so cross product is arrow. Kalau kita tengok, kamu first kena lukis something like this dulu lah. Arrow, AV and AZ. Okay, and then you go one by one. Arrow cross dengan AV, kamu akan dapat AZ. Whatever yang opposite dia tu, itu adalah jawapan dia. Okay, arrow cross dengan AV, kamu akan dapat AZ. AV cross dengan AZ, kamu akan dapat arrow. AZ cross dengan arrow, kamu akan dapat AV. Okay. Tapi kalau AV, tadi kita clockwise kan? So sekarang kalau kita anti-clockwise, which is AV cross dengan arrow, kamu akan dapat negative AZ. Okay, because dia dah anti-clockwise. Alright, again saya ulang. Kalau AV cross dengan arrow, kamu akan dapat negative AZ. Kalau AZ cross AV, kamu akan dapat negative arrow. Kalau arrow cross dengan AZ, kamu akan dapat negative AV. Okay? Right, kita tengok balik kita punya question just now. Okay, so we have this one. Okay, this is your DL and this is your R. So this is cross product. So DZ AZ cross dengan Z AZ, it will be equals to 0. Because kalau dia cross benda yang sama, AZ cross dengan AZ, it will be equals to 0. Okay? So next one, DZ AZ cross dengan row A row. So dia dapat apa? DZ AZ cross dengan row A row. Dapat apa?
AC. AC yang
AV,
Z.
yes. AZ cross dengan arrow, kamu akan dapat
AC.
AV. Okay. So tapi kamu kena tulis dia balik. So DZ AZ cross dengan Z AZ kamu akan dapat 0. DZ AZ cross dengan row arrow kamu akan dapat row DZ AV. Okay, kita tengok kat sini. So we have DZ AZ cross dengan Z AZ kamu akan dapat 0. Tapi bila DZ AZ cross dengan row arrow kamu akan dapat row DZ AV. Okay. AZ cross dengan arrow. So tengok AZ cross dengan arrow kamu akan dapat AV. Okay. Boleh semua?
Boleh madam.
Boleh.
Nasrul boleh? Khairul? Khairul boleh? Khairul Afiq?
Boleh madam, boleh.
Okay, good. Kalau boleh saya move on Alright, so kamu boleh tengok kat sini. So each time kamu nak solve these problems, kamu draw dia like this. Okay, so kamu boleh nampak apa cross dengan apa. Alright. Okay, so bila kita dah settle down dengan cross product tadi, so we rewrite dia balik semula. Okay, so it will be something like this now. So tadi kita ada I, DL cross dengan R. So DL cross R dah jadi row DZAV sahaja kan. So kamu tulis semula dia something like this. And then divide by 4 pi Z squared plus rho squared 3/2. So this is your magnitude R. Okay, so from here, again, kamu keluarkan semua yang kamu takkan integrate. Okay, so it is like this. So we will not integrate this I dengan rho. So kita keluarkan dia. So just left with this dz over z squared plus rho squared 3/2. Okay, so this one yang kamu kena integrate. So look again at this identity test. So which one that you need to use? So for this one, it is the first one, right? The first one over here. So kamu akan dapat something like this. Okay, I rho 4 pi rho squared z over this z squared plus rho squared square root the whole thing. Okay, so dekat sini yang banyak soalan before this, mana hilangnya Z before this kan? Mana hilangnya Z, Z pergi mana? Z tu ataupun this one in this case is row. Row ni nanti kamu dah cancel out. Okay, so bila dah cancel out, it's just left with one row sahaja kat bawah ni. Okay, like this. So row dia hanya ada satu je sebab dia dah cancel out dekat sini. And then because of we know that this line is starting from negative infinity to infinity because they mentioned tadi dia adalah infinite line current. So dia adalah negative infinity to infinity. So bila kamu masukkan dia, this will be 1 plus 1, dia akan jadi 2. Okay, so from this, kamu akan dapat this. Okay, I over 4 pi rho, 1 plus 1, dia jadi 2. And then 2 kat sini nanti kamu cancel dengan 4. So you just left with this one. H equals to I ni bukan 1, this is I. Divide by 2 pi rho and this is the direction which is AV, amperes per meter. Okay, if you need to find B, so it will be mu H. So you just need to add mu dekat sini which is mu I over 2 pi rho. Okay. And then this mu could be mu R mu naught I divided by 2 pi rho. Okay, understand? Boleh? Boleh semua? So saya tak nak nanti ada yang tak faham lagi. Bila sampai test rupanya ramai yang tak faham. Tapi masa kelas semua senyap. Boleh semua? Ada yang tak faham dekat mana-mana? This is similar macam electrostatic juga. Cara dia. Anyone?
Boleh, madam.
Okay. Boleh ya? So
Boleh.
kita continue. Alright. Now, if we have the line current dalam bentuk loop ataupun dalam bentuk ring, something like this. So macam mana kita nak solve the problem? How can we solve this problem? So kalau kita ada dalam bentuk loop ataupun dalam bentuk ring. Okay, so now this is your current. Okay, so first again, of course, bila kita tahu dia adalah line current, so the equation will be H equals to I dl cross R divided by 4 pi R cube. And then the next step will be you need to determine what is the parameters of the equations tadi. So you need to find the R, the magnitude R, and also dl. Okay, so if you look here, this is your R. So first again, kamu kena cari dia punya equation. The second one, kamu kena determine the parameters. Okay, so how to determine parameters? So you need to draw the line of R and then you need to find R. Okay, how to draw the line of R? So again, daripada line current kamu, okay, tak kisahlah sebelah kiri atau sebelah kanan, it will be the same. So it's better for you to take from here. So senang So from here, okay, dekat ring tu, kamu draw a straight line to the point of observations. Okay, from your line current, straight line to the point of observation. So that will be your R. And the other way ataupun jalan lain untuk ke point observation will be here. So daripada sini, start daripada tempat yang sama ya. Jangan kamu start dari sini sampai sini untuk R, tapi untuk yang lagi satu tu, kamu start daripada sini pula. Okay, it will start from the same point. Okay, jalan lain untuk ke point observation. So start daripada point yang sama. So it will start from here towards the origin. Okay. And then from the origin towards the point of observation. Biasanya dia akan pergi ke origin. Okay, daripada point here, daripada your line current towards the origin, daripada origin towards the point of observation. So draw the arrow ataupun the directions. Alright, then you can see. So because of that, so your R will be starting from here towards origin. So it will be negative rho arrow. Okay, plus dengan z because it's going up. Okay, it's going upwards, so it will be z. Kalau dia pergi ke bawah, it will be negative z. So now dia daripada sini towards the origin, so it will be negative rho plus dengan z. Okay, because dia naik atas. Alright, so kamu dapat your R, and now is what is your magnitude R. So the magnitude will be rho squared plus z squared and then square root the whole thing. And dl, what is dl? So again, dl is this line. Okay, this is your current. Okay, so your current is at rho dv punya line. Okay, rho dv av punya line. So that's why your dl is rho dv av. Okay. Alright, so this is your line current. So line current ni dalam follows this rho dv punya line. Dia tak follow z punya line. Alright. So ada soalan? Tak ada. Okay, so you have all these parameters. And then kamu just masukkan dalam equation tadi. Okay. Kamu buat ya, tulis ya. Ke dalam slide dah ada?
Dah tulis.
Tulis
dalam
ya.
Slide tak ada.
Tak ada, okay. So tulis. So make sure kamu tulis tu kamu faham. Jangan tulis tu kamu salin sahaja. Make sure kamu faham. Alright, kalau tak faham, tanya saya. Okay. Right, so kita masukkan dalam these equations. Okay, and then again, like I said before, kamu kena solvekan this cross product dulu, so it's easier for you. So now DL cross R. So we know that DL tadi is rho dV AV cross dengan negatif A rho plus Z AZ. Mana rho dia? Rho dia hilang. Okay, so again, dV AV cross R is rho Z Z. Okay, so how to do the cross product? So you can see here rho dV AV. So AV cross dengan A rho. So what will you get? AV dengan A rho. Kamu dapat apa?
AZ.
Ha? AV cross dengan A rho. Kamu dapat apa?
AZ.
Negatif AZ.
AV dengan A rho negatif AZ. Okay? Dapat tak semua?
Dapat.
AV cross dengan A rho adalah negatif AZ. Okay, tapi because of negative dengan negative here, it will be positive. Okay, saya ulang. AV cross dengan A rho, kamu akan dapat negatif AZ. So negatif dengan negatif, dia akan jadi positif AZ. Okay, so kamu darabkanlah yang lain tu. So rho dV darab dengan rho, it will be rho squared dV AZ. Okay, dapat?
Dapat ni.
Rho dengan rho dia akan jadi rho squared. dV akan dV lah. AV cross dengan A rho, it will be positive AZ. Okay, sebab negatif dengan negatif dia dah bukan cancel out. Dia jadi positif. Okay, you will get this. Okay, so the next one will be rho dV AV cross dengan Z AZ. So AV cross dengan AZ, kamu dapat AV cross dengan AZ, kamu akan dapat A rho. Okay, so that's why here rho dV AV cross dengan Z AZ, kamu akan dapat rho Z dV. Yang ni cross product ni akan dapat A rho. Okay, rho Z dV A rho. AV dengan AZ dah akan jadi A rho. Alright, so kamu boleh tulis balik semula. So DL cross R, it will be this one, rho squared dV AZ plus dengan rho Z dV A rho. Okay, so you can see here, this rho Z dV dia bilang, rho Z dV A rho is cancelled out. Why is it cancelled out? Kenapa dia di cancel out?
Sebab dia boleh either negatif ataupun positif.
Yes, because dia adalah symmetry. Okay, kalau kita tengok balik gambar, your line current ni dekat arrow punya positions. Okay, so that's why kamu punya arrow part will be cancelled out because this one will be equals to 0. Okay, boleh ya? And then kita masukkan dalam the equation again. So H is equals to integrations of I rho squared dV divide by 4. Mana pi dia hilang? Okay, sini ada pi. 4 pi and this is R. 4 pi R cube. Okay. I rho squared dV AZ divide by 4 pi. Pi dia ada 4 pi R cube. Okay, and then kamu solvekan dia. So if you look here, the one that you need to integrate is just dV. So take out everything out and then just integrate dv sahaja. Okay, boleh? So I rho squared divided by 4 pi rho squared plus z squared cube. Okay, and then you integrate dv. So dv is 0 until 2 pi. Okay, and then lastly you'll get this one as your answer. All right, so if given to you that the current is 10 ampere and z equals to 4 and rho equals to 3, so kamu just masukkan the value and you will get the final value of h is this one. Okay, and kita tengok balik z dia equals to 4. Mana z? Okay, z dia adalah 4. Daripada 0 sampai 4, so z dia adalah 4. Okay, jangan confuse ya. Kalau dia daripada negative 1 sampai 4, z dia equals to 5. Alright? Dia tak ada negative value kat situ. Dia hanya ambil dia punya value magnitude dia saja.
So Z tu dia punya berapa langkah dia ke atas atau ke bawah macam tu lah.
Yes, yes, betul, exactly. Okay. Alright. So dah salin?
No.
Make sure kamu faham ya. Oh, dah nak habis masa dah. Saya continue ya, nanti kamu boleh tengok video. Alright, so now we have infinite current along Y. So bila kita nampak something like this, which is along Y, okay, we need to use coordinate, Cartesian coordinates. Okay. Alright, so we can see here. Okay, so again, the equation will be h equals to integrations of I dl cross r divided by 4 pi r cube. And then what is your r? So r is berapa? Apa r dia? So r dia kamu kena draw starting point So the current is going that way, is going to the right. So starting from point dia adalah sini. So draw R from here towards the point of observation here. Okay, so draw your R like that. Daripada starting point of your current towards the point of observation, so that will be your R. Okay. So what is your R? Anyone can answer?
YAY plus XAX.
Yes, betul. YAY plus XAX, okay? Because it's going, so this is your R towards here. So the other way to the observation point is from here to the origins and towards the point of observations. So again, we're going to the right. So that will be the positive value of YAY and then positive value of XAX, okay? So that will be your R. Okay, and then what is your DL? What is DL?
DYAY.
DL is DYAY. Okay, so this is your DL because dia along Y axis. Okay, so your DL will be DYAY. Alright, so you have all the parameters. Again, bila dah dapat all the parameters, you do the cross product dulu where DL cross dengan R. Okay, so you can see here. So DL, this is DL cross dengan R, so you get this. So kamu buat dulu satu persatu DL cross R. So dy ay cross dengan y ay, this will be equals to 0 because ay dengan ay bila dia cross dia akan jadi 0. Dia tak boleh cross benda yang sama Bila dia cross benda yang sama dia akan jadi 0. Alright, so dy ay cross y ay will be 0. dy ay cross dengan x ax. So ay cross dengan ax, it will be apa?
Negative AZ.
Yes, correct. So it will be negative AZ. Okay, so the answer for that dia akan jadi dy x AZ, negative AZ, ataupun kita boleh tulis dia semula ix dy, okay, negative AZ. Negative AZ ni you can either put it here ataupun put it dekat depan ni pun boleh. Okay, macam ni, sekejap dia letak kat belakang, sekejap dia letak kat depan. Boleh je dua-dua. Okay. So this one boleh je nak letak kat depan atau nak letak kat belakang. Alright. Tapi bila kamu letak kat belakang, let's say nanti the answer from here akan dapat negative. So negative dengan negative dia akan jadi positif balik. Okay. So it's better for you untuk letakkan kat depan so nanti easier to see. Nampak, senang nak nampak. Okay, so this is the one, and then again take out benda yang kamu takkan integrate. So ix over 4, and then integration is this one sahaja, dy over y squared plus x squared, and then using this identity test, and you will get something like this. Okay, and then cancel out this x. Alright, so you just left with 1x. Okay, and then because dia adalah negative infinity to infinity, so it will be 1 plus 1. So that's why dia jadi 2 kat sini. And then you will have your final answer, negative 1 over 2x AZ. Okay? Boleh ya? Alright, so the next one. So the next one, okay, mana tadi? Okay, kita ada 1, 2, 3, 4. Okay, saya nak kamu buat semua ni. Okay, dekat dalam slide ni ada 4. And then if you look dekat notes yang ni, akan ada tutorial dekat bawah. Okay, this one the tutorial. Okay, this is the tutorial. So akan ada tutorial kat bawah ni. Saya nak kamu buat this one juga. So this ada 1, 2, 3, 4. See, sama juga yang tadi. Kalau sama tak payahlah buat yang dekat tutorial yang ni. Okay, 4, 5. Alright, so saya nak kamu buat semua ni part B sahaja ya, A saya tak nak. B sahaja. Saya nak each of you buat sebab next week saya akan tanya seorang-seorang. Alright? Boleh ya?
Boleh.
Baik, madam.
Okay, saya nak kamu buat semua sebab nanti next week saya akan tanya seorang-seorang, saya akan minta kamu submit this question. Saya tak kira lah siapa submit yang mana. Okay, saya akan pick randomly nanti siapa akan submit yang mana. Okay?
Next week ada kelas, madam.
Apa dia? Next week tak ada
week
kelas.
ada kelas.
Yes, the other week. So ada banyak masa lah untuk kamu buat. Boleh ya?
Boleh.
Kalau
Boleh,
kamu
madam.
stuck dekat mana-mana, you can WhatsApp and ask me, alright?
Alright.
Okay? Okay, right. Thank you all.
Terima kasih, madam.
Terima kasih.
Assalamualaikum.
Waalaikumsalam. Welcome.